urban wind turbine that VE Wind manufacturers started with an idea well over 6 years ago. The idea stemmed out of a need to bring clean domestic energy closer to home, literally. Many of us, including myself, have been in the energy business now over 30 years, have spent the last 11 years building large wind farms out in West Texas, out in California, and up throughout the Midwest. Really benefited from the energy that comes from these wind farms, but we saw a need to bring that energy closer to the load, closer to commercial users, closer to residential users. So we put a great deal of thought into what should that machine look like? What are the characteristics of a wind turbine that was going to be used in the urban environment? And some of the things that we felt were quite important were, number one, that it had to be quiet. Two, that it had to produce a reasonable amount of energy, maybe not all the energy that that particular building or end user would use, but a material amount of energy that they would consume, say 30, 40, or even 50% of the energy. And that realization drove a need to come up with the right size for the product. We started off with those parameters: quiet, size, and also cost. You can't embark upon a project like this without really thinking about the cost of the product as well. 6 years ago or so, we engaged the help of two universities, the University of Western Ontario and McMaster University, also in Canada, to help us using their wind tunnel facilities, their computational fluid dynamic capabilities, to optimize a wind turbine that met those parameters. And what we ended up with was a turbine that looks nothing like what you typically see when you think of small wind turbines. The urban wind turbine has two vertical axis rotors that actually are not connected to each other, but run in harmony with each other. What's also included in the product is a nose cone that directs the wind, the oncoming wind, towards those rotors to make those rotors more efficient, more effective in producing energy. And what we learned through the wind tunnel testing is the configuration of the product, the shape of the blades, the distance between the rotors, the orientation of the nose piece relative to the rotors, all things that over a period of years we've tested both in the wind tunnel and also through computational fluid dynamics to come up with the product that we have today. Now, having a product idea and actually having a product that people want are two very distinct things. And we were lucky to come upon VE Technologies, and today VE Wind, who took our product concept and our designs and made it a reality. Using the aerospace industry tools that they have here, the computer-aided design, the 5-axis machine tools that they have. We made several prototypes that we ultimately have tested, and with very favorable results. And so over this 6-year period, we were able to go with a concept and an idea of bringing this clean domestic energy closer to home, to just thinking about what was needed for that to happen, to thinking about what a product would look like, to testing various designs and optimizing designs, to coming to a company like VE Wind to help us make a reality of it. And we have today a product that we're sharing with you on this site that we hope you enjoy and someday can hopefully benefit from the use of.